This JMP demonstration shows how to calculate a tolerance interval. JMP implements two methods for computing tolerance intervals, one that assumes a population that is normally distributed, and one that doesn't make any distributional assumptions. We'll begin by calculating an interval that assumes normality. We'll use the coding sample dataset from the sample data directory and calculate a tolerance interval for the variable weight. We'll start by going to Analyze, Distribution, placing weight into the Y columns role, and clicking OK. In the distribution report window, we'll select tolerance interval under the red triangle. Next, we can specify the confidence level, the proportion of the population distribution that we'd like to cover with the interval, the sidedness of the interval, and whether to assume normality. We'll use the defaults here and click OK. Our distribution report now contains a table with the proportion of the distribution covered by the interval, the lower and upper bounds of the interval, and the confidence level. Our results indicate that, with 95% confidence, we believe that 90% of the true distribution of weight values falls between approximately 17.3 and 23.5. Next, let's compute a tolerance interval using the nonparametric method, which doesn't make any assumptions about the shape of the population distribution. We'll use the process measurement sample dataset and calculate an interval for the variable process1. We'll use the distribution platform as we did before, and judging from the histogram, we may choose not to assume a normally distributed population. So when we select tolerance interval under the red triangle, we'll choose the nonparametric method instead. As before, our results table includes the proportion of the distribution covered by the interval, the lower and upper bounds of the interval, and the confidence level that we specified. Because with this method we may achieve a higher confidence level than specified, we also have a value for the actual confidence level achieved. These results indicate that we have 97.6% confidence that 90% of the population values lie between approximately 5.2 and 17.2.